dice goes, I'm starting. Okay, so we are going to do, so I pulled the 4 out, but we have this cosine squared of 2 theta. So I handed you the trig identities. But there's 2 options. I personally remember this one better. So I used this one. It's 1 plus cosine 2 theta over 2, right? Yep. So the other identity that you could use is that the cosine of x over 2 is this, plus or minus square root 1 plus cosine x over 2. The reason the second one can be used is that your argument, so the terminology is it's your argument, the thing that's inside the cosine. So inside the cosine is 2 theta. And when I put 2 theta in for the argument here for x, or I guess for x, it'd be then just theta. Okay. Now, I don't love that because it's kind of, I don't know. This one's easier for me. But when we put in theta, it's really going to be 2 theta because your argument is 2 theta. This argument's theta. So you're like, you got a double 2 there is what I'm saying. So you don't want to use the double angle then? You do not because it's squared over 2. So double, I guess you could use the double angle twice. I'm sure that would get you to where that is. Yeah, you can do that too. Okay. Yep. Either way, it should get a version of that. Either way you get it. Okay. So then I'm going to pull the 2 out. So then I just have 8, 0 pi over 4. And now it's just 1 plus cosine of 4 theta d theta. Okay. Now we haven't done antiderivatives by hand in a long time. What's your antiderivative of 1? Careful.
0.
Theta. And then I have an 8, so it's going to be 8 theta. Okay. Now I have the 8 again. Antiderivative. Antiderivative. Yes. Antiderivative. Okay. How do I do it with cosine of 4 theta? So it's technically a u sub with that. In other words, you're going to put it over 4. And then sine of 4 theta, and we're going to evaluate from 0 to pi over 4. Okay, so some of that little basic u substitution stuff will be coming back. It's been a while since I did the homework, but I don't remember any like integration by part stuff or any craziness. I think it was mostly straightforward. Okay, so plugging these in then, this would be 2 pi plus 0. When I plug in 0, they're both 0. So this whole thing is 2 pi.
So
I put in pi over 4. So 8 times pi over 4 is 2 pi. The sine of 4 times pi over 4 is the sine of pi, which is 0. And then 8 times 0, sine of 0 is 0.
Oh,
so I just plugged in.
When we went back to antiderivative, we just like pulled out the 4, the 1/4, like the.
Yeah, so that your u substitution would have been u equals 4 theta, then you would have had a 4th, blah, blah, blah. Okay. Now, here is what I caution you of along the way here is I would set it up for like, here's the total area. So like putting that 8 times right away. Sometimes I have seen people when they do, it's the volume version of this, but if it's like double or something, they're like, oh, I'm just going to do the single and then I'll double at the end. And then they totally forget to go back and double. So if you're going to do something like that, I would just set the whole thing up right away. And then your constants will just kind of stay in the front for a while. And you don't have to worry about forgetting to multiply at the end. Okay, let's go to the little more challenging ones now. Well, that was just the trig. It wasn't nothing in there. Was that
What's a cardioid?
Cardioid? That's cardio. What's cardio? What? That's cardio. I'm like, what are you talking about? Cardio.
Cardioid.
Cardioid, I did.
Okay, so we're gonna do these 3. Did I give you a big open page? Okay, yeah, because I've fit mine on the tiniest little thing ever. All right, so consider we have a circle with r equals 1, and then we have the cardioid is 1 plus cosine theta. So first and foremost, get it graphed. So I'm going to put both on here. So 1, and then 1 plus cosine.
We're going to get a calculator on the
Because
test,
of the
right?
fix.
Yeah.
What's calculator?
How about this sheet?
When I calculate 2
No, you don't want to use it that much. Now I changed my step to like only go to pi over 2, so I got to go back to like, I don't know, 2 pi, 4 pi, whatever, 2 pi. Something bigger.
Oh my god, you're gone. You're so dumb.
Okay, so here is my picture. Okay, I got a circle, and then I got what I affectionately called the butt, if you remember.
Because of the prefix. Bro.
No, it's a butt. It's a sideways butt. Okay, so I'm gonna draw a nice little picture, the nice-ish
You're gonna
picture.
draw a nice one. What?
A nice,
Nice little picture.
as nice of a picture as I can
What you
muster.
did? I drew a nice little butt in the ground.
Actually, I don't know if that's good, but whatever. Okay, let's talk about intersection points. So sometimes you might have to actually find these by hand, and because we're going to find the different sections as we go through these. So let's just start with intersection before I get to like any of the other one. Intersections. So I set them equal to each other, right? Because it's so 1 equals 1 plus cosine of theta.
That's what it looks like.
So 0 equals cosine theta. And where does cosine equal 0? Plus or minus pi over 2. Or 3 pi over 2.
Silent.
Either way.
Wait, what? What does that say? Intersection.
Intersections.
I saw that. I know what that.
Yes.
Are you okay?
No.
That's right here and right here.
Oh,
Okay. On the graph, it looks like
Why is it
cardioid is bigger than.
wait, no, they're at 0, aren't they?
Wait, why are there 3? Oh, what?
We're looking where the two functions intersect each other.
How do we know it's pi over 2 and not 3 pi over 2?
But picture
That's a good
the-
question. I don't know why I did that.
Look at my picture.
So
My
what are
picture's better.
What area are we trying to?
Yeah, they'll look like what we're talking about.
Same thing. I mean, if you, I don't know why I did negative pi over. I don't. In the examples, I never used negative pi over 2. So
So
same thing.
Wait,
Where?
so are we doing?
Well, hang on. It was just this. I'll have picture and intersections. Okay.
but like, why doesn't a calculator make it look that way? Why does the calculator make it look like it doesn't intersect that way?
Oh,
Did I
my
put it
picture's bad.
wrong, or like,
Oh, it crosses right here and right here. So the calculator, my
My
sketch isn't great. So here's pi over
Is that
2.
how
Here's
they do
3
it?
pi over 2.
Stop insulting her sketch.
Yeah, my sketch is terrible. It's okay.
I don't know what the
you
answer
can't
is.
do the intersection.
Why is it 3 pi over 2?
Well, it's the same thing. So negative pi over 2 is the same as 3 pi over 2. That question was asked, so I just wrote both things there.
Oh,
It's the same.
I see.
Okay, here.
So there's
Yeah.
3 intersection points?
So to find the
No.
intersection, guys, you still gotta do like the.
But you have
There's
plus or minus.
Because they're this. Oh, jeez. They're the same thing.
Okay, so it was
No, it's where.
Okay, here.
You just say what cosine theta equals 0.
I'm fixing my graph for everybody hating on my graph. Here's the intersection. Let me switch colors. Intersection. This is negative pi over 2, or it's 3 pi over 2. That's the same thing.
Oh, it is?
Negative pi over 2, 3 pi over 2.
Yes.
They go to the same.
Oh, that's why I was.
Sorry.
Wait.
Yeah,
Trig.
but so is I. It's
Negative
just
and
like-
a negative angle just
Why do
opens
we have
down
3?
instead of up. I know everyone's like freaking out about this. Okay, on A, it says find the area of the region outside the circle and inside the cardioid. Okay, so this is going to be a very rough sketch, so no
So we're
judgment.
gonna find this area.
Okay, that sketch was actually better than the first one. So
It's
we
actually
want
really well.
outside the circle, inside, so we want this part right here. And that's what that's describing.
Doesn't it say inside the circle?
No, outside.
Outside the circle for A, this is A.
Yeah.
Outside the circle and inside the cardioid.
Looks like a burning pop, dude.
Okay, now you want to find symmetry. Don't. I didn't come across any that did it without symmetry, to be honest, or if it was just one section, then that was it. But so like in this case, just do the 0 to pi part. So this is 0, yeah, pi over 2. Just do that part and times it by 2, right? So you got a half then because of the area. So we are just going to do the top half, and then the bottom is the same because they're symmetric. Right? Okay, and then we want outer minus inner. So outer radius arc.
So 1 plus.
So your outer one is your cardioid. So it should be 1 plus cosine theta squared minus 1 squared d theta. Okay. Now I am going to do the couple of these by hand. One I probably won't because it's chaos, but
So is it
Go.
times 2 because it's like,
because I only did from here to here
yeah, and plus the bottom. Okay.
plus
And times 1 has to just be 1.
from the
Yes.
Well, at least I understand what
from the equation of it.
we will get.
Why couldn't you just do it?
I don't know if it'll work, to be honest with you.
Two to the second half?
Well, and you would have to do it in 2 pieces because you can't keep going. Okay, so one reason I know you can't just do the whole thing, and maybe you could do negative pi over 2 to pi over 2. I'll type it in while we're going there. But like I can't say 0 to all, 3 pi over 2 because that's including all of this and that's not part of it. Maybe that's why I wrote negative pi over 2 in my brain.
Okay.
Okay, so doing this by hand then, okay, how would I do this? Well, okay, algebraically, what do I need to do?
Simple or foil.
I need to FOIL, okay? So the 2.5 are gonna go 0 pi over 2. Okay, I have to FOIL that thing, so that'd be 1 plus 2 cosine theta plus cosine squared theta minus 1 d theta. Okay, so my 1's go. Okay, this 2 cosine's fine,
Cosine
but the cosine squared, I'm going to switch to 1 plus cosine 2 theta over 2 d theta. Okay, and then this is like, these are just, if I split up the half, so it's a half plus cosine 2 theta over 2, I can take my antiderivative. So I have 2 sine theta. The antiderivative of a half would be a half theta. Okay, the last term there, I have a half because there was the divide by 2. I would have another half because it'd be u substitution for that 2 theta. So it'd be another half. And then sine of 2 theta, 0 to pi over 2. So you'd have technically that cosine of 2 theta would be a u substitution. You'd get, u du equals 2 d theta and move the 2 over, so there's a half.
Oh.
Okay, so plugging.
Why couldn't we have added, like, if you split up the 2, why couldn't we have added the 2 cosine of theta and the half cosine of 2 theta?
Why couldn't we have added? Say it again.
So, like, if we have like 2 cosine of theta plus a half.
Yep.
Plus a half cosine of 2 theta.
Yep.
Why couldn't we have added? Oh wait, never mind.
They have different arguments. Yep.
Yeah.
They have different arguments. Yeah, so you can only combine trig functions that have the same argument and have the same thing, sine, cosine, whatever it is. Okay, so now plugging in pi over 2. So I'd have 2, the sine of pi over 2 is 1. Pi over 2 times a half would be pi over 4. This would be a fourth times 0. The sine of pi is 0, yes.
So just 2 plus pi over 1.
Okay, plugging in 0 does end up giving you 0 plus 0 plus 0. Be careful though, not all the time when you plug in 0 do you get all zeros. Just so happens on that one you do. So this is 2 plus pi over 4. And again, because initially I set it up with that symmetry, I put the times 2 there right away. I'm done. I don't have to like think back and do the, is this right?
All right, no.
Okay, now B, we're going to set up and we're going to type in our calculator to make sure you can use your calculator because I do want to make sure that's a thing as well. Everybody good on A? All right. B, 1, find the area of the region inside the circle and outside the cardioid. So if I draw my little sketch again, so that would be this little piece here.
Oh, so the left side.
Yep. Yep, basically the left
I
side.
made this side line.
I got the same answer for it.
Look
Did it.
to the, oh, don't flip it
God,
back.
you're so bad.
Okay, so on B here then, again, we have the symmetry. So I'm going to have 2 times. I've got a half. What's going to be my bounds?
Pi over 2 to.
Yes,
Or pi over. Yeah.
pi over 2 to pi. Because you're going to use this top half, and then we're going to times it by 2.
I I don't know how you're getting the bounds though.
So this is unit circle. This is pi over 2. This is pi. This is 3 pi over 2, 0. Because you're on you're on an unit circle. You're not on an XY plane. Because you're R in theta.
You have to switch your graphing.
Yeah.
I know, I also did this.
So Ava, think of it as this. This is your Ava.
Yeah.
It's this. Like you're on
Yeah,
this.
yeah, okay, I get it now. I get.
Oh, that makes way more sense.
See, me.
That's why it looks like it was like a 0.
I was like, I don't know. It's gonna. Okay.
Like, wow, scale
What would be your outer arc? I gotta stop saying radius. What's your outer arc? 1. So this would be 1. I'm gonna write squared because then technically, and then your inner arc is your cardioid. So 1 plus cosine theta squared d theta. Okay. Type it in your calculator. Make sure we can do that as well because that is a skill you need. I need the decimal answer.
That's pretty good.
Good for you.
Oh, I did the next
Good
one.
job catching up. Ava.
Math. Oops, I don't want that. It should be 2 minus pi over 4. It should be 1.2146. Hopefully.
No, I didn't say
And
that.
I did it by hand,
Really?
so
Did not
it's always
say that.
possible that.
Behind the hand.
1.214.
Yeah, okay, I got it right then. Okay. Then I'm not going to.
1.215.
Okay, I want you guys to try C. So take 2 minutes.
You gotta distribute the.
Try C.
No.
Oh wait, we can just plug in our calculators.
That's what I just to make sure you can do both. And I'm gonna look.
Oh, I was about to say, I was like, oh, a decimal.
I'll tell you what number you have to do by hand until
That's
on your homework.
One is inside the circle and
Why?
inside the
It's the last section.
part. It's the last section
Doesn't
we
look
haven't
good at all.
done.
Yes.
So
So
it's not,
essentially,
and it's not meeting the whole thing
right. It's just so it'd be like this part right here.
inside both.
Yeah.
Okay.
Okay. How far do I want you to do this by hand?
Get over it.
So is 0 just pi over 2?
No, it's me.
Zero.
No, that's what
It's
you
28.
It is zero.
Well, you can do 2 separate.
I was just gonna do 2 separate ones, yeah. Zero.
Multiply to get to your C value.
Yeah.
Yeah.
So it's 1.
See this before, so you might think that-
Okay, no, you have to, hey, I think you have to split it up as 0 to pi over 2,
Yeah.
because
And
the
then you have to
inside's
do it.
split.
It'll be much easier if I
Inside
look
one
at
shifts around, because see how the circle is on the outside, and then, or the circle's on the inside, now it's really on the outside.
Remember, when we're labeling our A, B, and C, A is the number
Inside the circle, inside the cardioid.
So you
But-
do have to do like the dy.
Wait, so
stuff?
we're just finding the area of the code.
Like you're in dy.
Oh wait, no, never mind.
Did we stop?
Never mind, never mind, never mind.
You have to be in like dy
Yeah.
type thing. Remember we had to do that in terms of this dy or dx?
No, they're all just theta. I mean, they're all in terms of theta. There's no x and y, so it's all.
No, I know, but like when we did them before, we did dy dx because like if you use
For the derivative?
and C is.
Are you talking about old stuff? Are you talking about today?
old stuff.
Yeah, so it's
Um,
just one square.
Because we had to determine if it was dy dx.
That was when you were like spinning around stuff
This
or
way you
doing
can also do
area.
that? So what would you do? Because it's would you do right, minus left?
This one,
The number of that
so I did it in terms of like a shape, and then I found I only did one integral, but I did do the area of a shape.
I did 2 and.
Oh, so you need to find where it intersects the line.
No.
The
Oh.
plane. So you need to turn it back. I'm just gonna-
Let's see.
If you go 0 to pi over 2, what equations do
We
you
don't
plug
know.
in?
Colin, is this what you did for your setup?
Okay, hang on.
Why do you put it in one hand?
We'll have to see. So I didn't use 2 integrals. If you use 2, let's see if they're the same. I just did a semicircle. So it's 1/2 pi 1 squared.
Don't do the 1 squared minus this.
So that was like my
Just do the, oh, yeah.
This part?
Yeah.
circle.
Okay, yeah, I get that.
Yeah, and then I just added it to my little
What?
bumps.
But why couldn't you do it all?
How
would we do 2 different integrals?
Y'all
You okay?
do extra drawings. I just.
You've got to be. Hang on, guys. So if you were doing integrals, I would guess, and I didn't do it this way, so I'd have to try it, but that you would do, so like 0 to pi and then red, so the cardioid minus the circle, but then you also need to go add in the cheeks of the butt to say it. No, I mean, what else you call? I don't know what to call them. The tops of the heart, but you've got that extra part. So like if you just did cardioid minus circle, and then times 2, you would find
the shape in between. So if you just do like one square, because you want just the circle, so the
yeah, right. That's what I'm saying. So you want this blue part of the circle. So that's where I did the semicircle, and then you want the little humps.
So do we still multiply by a half if we aren't like minus the inner?
No, like the
So
yes, if it's an integral, yes, there's a half.
Okay.
Okay, so hang on. People are doing side conversations, and we're all getting confused. So to find this part, I just did a semicircle.
Yep.
So there's no integral, so there's a half there because it's a semicircle. But here, let me get a color. So like that, like this part is pi over 2. So then I need to add in those parts. So it looks maybe like a peach, the top of the peach.
Oh, so we just know that that's the area of the semicircle because of the 1 unit long.
Right, because it's a radius, circle
So it's
radius
just
1.
Pi over 2.
So then I just need the half pi over 2 to pi, and I'm going to have 2 of those, so times 2. Oops, I don't know, I put an extra one in there. And this is why the pictures are important, and then not everything is just like out minus in, and like you got to kind of piece together and find that symmetry. I need to find just that segment. So it's just your cardioid, which is the 1 plus cosine theta squared d theta.
Why couldn't you do 0 to pi over 2?
Divide by triangle.
That's 0 to pi over 2? Like the whole circle?
No, the section.
What's the answer?
The answer is 1.92699.
Boom.
I got 1.92732.
That's
Why don't we square the one?
Both of
plus
these two are
cosine?
because that's how you find the area inside a polar function. So we just don't have that part, right? It's just because there's just one. So it's the half cosine of the function squared.
Okay.
That was the double one, but
Just
Why did you
ignore
divide
that.
this one by half? And this one by half?
Why couldn't you do 0
What's the
to pi
point?
over 2 and then do the right minus left, so that would be the circle function, which is
It's not even one big.
well, because so there's no right minus. Okay, the idea of right minus left doesn't really fit here. It's outer arc minus inner arc, and as you go around the circle, it changes what's the inner and outer arc. So you can't. It's not just one.
the both times it's the inner arc is the.
So you're finding this part right here. Yeah, no, but I want the inner area. If you do that, then you would. What you just said would be this part right here. You don't want that part.
How would it be?
Because you said outer minus right minus left.
Yeah, no, the right function as in,
This cardioid.
Wait, why did I get
No.
that answer?
the circle.
Get what?
No, the right function's the cardioid though.
What did you do?
So maybe that's the issue. This is your circle.
Yeah, the circle.
I didn't
Minus
Is the left
bump
function.
part on the butt.
Oh, you're talking about. You said from 0 to pi over 2, which is
Yeah.
talking about this quadrant right here.
Yeah.
So that's not involved because that's past pi over 2.
Oh.
So you're talking about only that part right there.
So that would work for just the circle part, but that's basically what you're doing, just way simpler.
Exactly. So yes, if you did this pi over 2, 1 squared, and you got the half d theta, yes, that's the circle, but you can just do a semicircle and you don't have to do all that. That's
Oh
the
wait, so
difference.
then do you get 2.35 or whatever?
Okay. So pictures and kind of like I said, just
Okay,
look for
so
some
you
symmetry
have
stuff.
1 plus power,
Yes.
right?
Okay, we gotta do arc length and then one more example. Hang on, I'm gonna get rid of this because
That's just all I got there.
oops. Okay, so there's your blank page. All right. Arc length. So you've done arc length in a couple different contexts. You did it normal. You did it with parametrics. Here's your polar version. So I figured we'd do one. I don't know. I made up one example to throw in the end. But let's just do the cardioid that we had above. And we'll type in our calculator, but,
So you
oh, actually, we won't type in our calculator. We'll do some
your
math.
math wrong, you just wrote it down.
Multiply to get our C.
Okay, so when you're doing these, same idea.
Yes.
We're gonna use some symmetry, so I don't need to do the whole thing. And so we're doing the arc length of this, and what was to say, what's the whole arc length? Like how long of a piece of string do you need to make this? So we're gonna just say 2 times, and we're gonna do the 0 to pi because again, it's symmetric. Everything you symmetry. Is there a way to do without it? Okay. Square root. Guys, move on so we can get this done. Colin, move on. Okay, so r squared would just be 1 plus cosine theta squared. Okay, then I want r prime squared. So let's list out what r prime is. So that would be negative sine of theta. Yeah. And then that thing's being squared. I'll write it in there, but it'll just go positive. Theta squared d theta. So as you're prepping for your AP test, just make sure you have your 3 arc lengths. They're all very similar with each other, but make sure you know all 3 of them, I guess now. Okay, so let's do this one by hand, just again to get some of that trig stuff in here. So I'm going to leave my 2. I'm going to square the stuff in here. So first one will be foiling. So 1 plus 2 cosine theta cosine squared. Sine squared would be that one. D theta. Okay, now sine squared plus cosine squared, there's that 1 showing up. So this is 2, 0 to pi. This would be 2 plus 2 cosine then. D theta, sorry, that part.
It feels like it's.
Now, for simplicity, I'm going to just kind of take out the, I'm going to factor out the 2. It's still under the square root currently, but it's 2 and then 1 plus cosine theta. Oops, parentheses, d theta.
Oh, back to 1 plus cosine.
Okay, now the reason we're having to do this is because all of this is under the square root. Okay, before when we were doing these substitutions, it was like, oh, no big deal. Like everything was adding and subtracting once we got that substitution done. I have everything under a square root. I can't do a u substitution right now because I have a cosine in there, and so I'd get sines and everything all over the place. So I can't do that. So I need some other substitution that will help me. Basically, if I can get something squared under there, then I can actually do the square root. So what happens is if this,
Oh no.
that's really close to, where's my little trig identity? It's really close to cosine squared. Okay, what's different about it though?
So is it 2 cosine?
The 2 theta.
There's a 2 and the argument, okay? But what Yes. And so what I can do, I'm just going to keep going. So, well, I'll just go this way because I did that. 0 pi. Pi. So the 2 is still there. Theta. So this would become 2 cosine squared of theta over 2, right? Yes. Theta over 2. So it's some manipulation of what your original was. Because your original was cosine squared of theta equals 1 plus cosine 2 theta over 2. Okay, so this 2 is where that came from. Your argument was just double. Right? If it was theta, it went to 2 theta. Or in other words, it was half if I'm going to the squared. So half of theta is theta over 2. It's kind of a weird manipulation. And again, can I say that's going to be for sure on your AP test or not? I have no idea. But
Can you compare that again?
yes.
Yeah.
Okay, so here's your identity. Are you with me that that's the identity?
Yeah.
Okay, so I have 1 plus cosine and then an argument. We'll just go like this. Argument. Forget what's there. Okay? And so I want to manipulate, I don't have this divided by 2, so I would multiply 2 over. Put that back there. You agree with that? Okay. Now, what's under my squiggle is double this. So like if this was a 4, this would be an 8. If this was an x, this would be a 2x. In our case, it's a, come on.
And we want ours.
And so we want to do like what is theta to make these work.
Okay, so right now it's theta, and the cosine squared has to be.
Whoops.
And that, okay.
So like this is just theta on ours, so that means it's theta over
Yeah.
2 in this one.
So if it's bigger,
Okay.
divide by two.
It's like a weird manipulation of it. It's dividing your argument by 2 to make a match.
And you multiply that to, oh, right, that's right, that's wrong.
Yep. Okay, where did I put that over there?
I totally agree with what you just said.
So now I have the square root of 4, like 2 times 2 is 4, right? These two are just 4. So now I have 2, I can square root it, it's 2 now. 5 over 2, this is now this. I'm just showing a couple extra steps here.
So cosine.
So this is 4, and this would just be cosine of theta over 2
Perfect.
d theta.
I am so on.
So that,
It's okay.
I actually understand.
so
I mean,
eight sine.
Just if the substitution messed you up, don't let that mess you up. Like that is true. Hopefully you have a calculator. Just do it that way. But then from there, now we're just square root squared. Okay, now in this case, when you do your u substitution, what's it going to have on the time? It's going to multiply by 2 instead. So this is going to go to 8 sine. My brain stopped.
Theta over
It'd be
Theta over
negative.
2. No, because it's antiderivative.
Oh, that's right.
And then 0 to pi,
Antiderivative.
which just gives you 8 once you plug everything in.
Okay.
It
How about just make it true?
negative.
Where's the 8 come from?
So the u substitution of this would have a half and then a times 2 over.
Oh,
Imagine
antiderivative?
how that
Yeah, the
Oh,
antiderivative.
right.
Yes.
Now we know the full length of that.
Well, you could just put it in your calculator.
That's what math is.
Okay. Okay. So just before we have to do example 5.
Example 5 and.
No, we don't got
Oh yeah. Okay. No, it's just the beginning of it, not anything
Go
other.
back.
Yes. Before we do that, I just want to connect polar and parametric because they actually can be used interchangeably with each other, and I'll show you how. Not this step. It's just a. It's
No.
don't worry about it.
No.
Oh God.
You're very good.
Wait.
Sorry.
I feel like I both know what I'm doing. The one like I don't try to do the homework and then be like, sorry.
Which part? This?
No, just like,
I don't understand that.
Guys, I typed it.
Okay. Did you get this? The squaring and the combining.
You're just plugging in.
Yeah. So like yeah. So if that, don't let that part be like, oh, this I can't do this assignment. It's just a trig of substitution. That's really weird. And chances are it's not on your emails. And I didn't do it on homework. That's the end all be all. But I'm showing you everything. So
All I need to know.
okay. I'm just kidding about the polar thing. Okay. So in some of your examples, they ask you to find, like you have to find those intersections. Okay. Sometimes there is what is called hidden intersections.
No.
what?
And you have to have a calculator. And honestly, I would bet that you would do your intersections with the calculator anyway, and you wouldn't even do them algebraically. So and part of me is like, if you have a calculator, you're just going to go use your calculator. So it doesn't really matter. But I'm going to show you how to do them I'm going to show you why it happens. Okay, so here are 2 polar functions. We want to find their intersections. So you're like, okay, set them equal to each other. 1 plus cosine theta. The other reason I thought this was good is because algebraically, sometimes we struggle with this because it's easy. what would you do to solve this first?
I was-
Yes, you subtract cosine, and when you do that, what do you get over here?
Two cosine.
Thank you, because sometimes we say just 3, because your
So,
brain is
cosine
used to.
theta equals 1/2.
So cosine of theta equals 1/2. Okay, and then you would need to be like, okay, when does that happen? Well, that would be at pi over 3, and then either you can say negative, depending on what's happening, you probably use negative pi over 3. Again, there's gonna if it went on and said what's the area or something, you're gonna do the symmetry, so it doesn't really matter. You could also say it's 5 pi over 3, right? Those are the same. I'll say slash. Like those are the same thing.
Oh, isn't there a way to be like, pi n over?
Yep. Well, I'm not. Yep. Well, okay. Let's graph these on your calculator though, because there is another intersection point, and we'll talk about why you don't really get it algebraically, but there is another one.
Do we have to go back to normal?
No, these have thetas in them. So 3 cosine theta,
Algebra.
1 plus cosine theta.
Oh, you get one.
Oops, I got a 1 in there.
Clear. You're a grab.
Oh crap.
Wait, I don't, why is the red one not? So there's 3 intersections?
So where else do you see one?
Oh, no.
Get
That's
anatomy on
At the
us.
butt crack.
The butt crack is gone. No.
So, okay, first of all, the other 2 are hard to see. I'm going to change my window so you can actually see them.
You're grab.
I think you grabbed
Oh, you've got the
wrong thing.
+1 on the cosine.
Oh, you're in it.
Yeah.
You right,
All right.
Which one has it? Oh, my
No.
cosine. Yeah, that's only in Calc 1 you get a movie day.
R.
They get
There.
a movie day?
It's a pig
After their
farm.
AP test, yeah. You watched
We
it.
watched it. We're not gonna be
Yeah.
here. We
Oh,
watched
we
won't
got a movie
That's right.
there?
Okay.
I thought we just went.
Where else is there a intersection point?
Right at.
At 0. Well, at the origin, at the polar. The pole. It's called the pole. It's at the pole.
On the free response, where do they intersect? At the butt crack.
At the butt crack. I mean, I would be a little proud. I'm not gonna lie.
I would totally
You put that on the
write
AP test, and you actually get a point.
I know, just write that. The
I hope
next-
it's like 2 years ago they released everyone's free response, so I can go see what everybody wrote. Okay, so these things also cross at the. It's called the pole in your mind. Think of it as the origin, right? They also cross at the origin, but here's why you don't get it algebraically. It's because they're.
Because 0.
Yeah, what's the North Pole? Get it, North Pole. Okay.
North Pole's in
Oh, is it because they like
They
touch and it's like even
They
response?
don't-
no, it's not. It's that they hit it at different times. So if I go to my table, I don't know what my table's set at.
Oh.
So they're both hitting that value, but they're not doing it at the same time. So one of it is doing at what is that? Pi over 2, 0 pi over 2, and one of them's doing it at 0 pi. And so because they're not hitting the value at the same time, this algebra doesn't work because they're not doing it at the same time. And that's what it's called hidden. And literally the quote from the book, there's no foolproof rule for finding the hidden intersections.
So
Just graph
it.
So graph.
What if
So
I invented a rule?
My
you
rule
would.
is to
You
graph.
totally would, yes.
Ayo,
How
at
do
the
you
butt
make
crack.
I don't know.
Fine.
People research, some people's jobs is to research math and they just do.
So
I don't know, it's your
No, the rule is called confusion.
Okay, I do want to show you this, that you can in that menu. So in your Calc menu, there was like, you can find some derivatives, right? If you want to check a derivative on there, that's on there. You can get values of stuff. You know, I talked about manipulating your table to try to go, I think I might set at pi over something, 4, something. But manipulate it so you can see your main ones that you want. You can adjust what graphs to see, like, do you have the full, when I went 0 to pi over 4, I could see I had the part of a leaf. So just be strategic, have a calculator handy and use it a little bit here. That's not what I wanted. I want your homework. So that's it. This was a lot. This is the longest section by far in terms of that. On your homework. So here's how we're going to do. Whoops, that's not what I wanted. This one.
I don't think I'm.
Oh, we're doing one part first?
No.
No,
I failed that last.
No.
must show
I
where.
retook it to get a C.
What's
Oh,
your work?
Sorry on that.
What are you talking about?
No.
So I only picked
So-
6.
so you do 6 by hand, and the other ones you can just use your.
Set up and
calculator.
tight. Yes.
Oh, I'm happy.
Alright, that's fine.
So
We accept.
so for the first 6,
I guess.
it's yes, but it is good like trig practice. Okay.